Welcome everyone. Thanks for all joining in our KQLCafe episode October 2024. As always, your host, Johnny, myself, passionate about KQL and a lot of other things. And our agenda, nothing changes. A big welcome to everyone. Then we kick off with a few updates around whatever I found on the subject of KQL in the news, in the tweets, or in the X's, I should maybe say, LinkedIn, whatever things we find worthwhile for you to know. Again, today we have our guest, Koos Goossens, who will talk about Azure Data Explorer and much more.
Thanks for having
Learning
me.
KQL. And last but not least, as always, what did you do with KQL this month? Now, so far, it has been mostly, contributions from Johnny and myself. But today, I'm happy that actually someone popped up and said, "Yeah, please share my thing." And I know I repeat myself, but don't feel like you have to submit your 50-line KQL code. Sometimes the beauty is in the simplicity, and it's about the use case and not about the lines of code. So if you ever feel like, hey, this is worth sharing, let us know. And otherwise, of course, submit it to the KQL search engine. Okay, let's kick it off. What's new? Well, first of all, this is something we are super excited to also let our KQL audience know. Maybe you lived under a stone and you haven't seen all the tweets and the buzz we made about this. So yeah, we love this KQL format. We do it every month. But one day Johnny told me, I want to do something bigger. I want to do something that, goes longer than just 1.5 hours. So we developed this idea. We were able to gather a bunch of other KQL enthusiasts. And with that, we are happy to present to you that on the 8th of November, on Friday evening, I know, including me, usually I go rather out for beers then, but please, this Friday, November 8th, 1400 Central European time. So we also try to accommodate for other time zones. That's why we start in the rather, afternoon. And here you see the agenda that we have. So we kick it off with Johnny and myself. Also for those that have never heard of KQL, we run a session on why you should practice it. So I guess you who are already here, you are already convinced. But we take a little journey and help those people who take this initial session at the KustoCon, to do a jump start. Then we have further speakers, as you can see here in the agenda, that talk about all their own experiences and expertise in the area of KQL. Below you find the link. There you find all the information, the agenda, how to register. That's pretty straightforward. We'll use the meetup registration form as you are used also with the KQL Cafe. So far, we already have 550 people who RSVP'd. Let's hope they also all join. We also have great support in the whole video production. So this is really going to be a super exciting session. So if you can, mark your agenda and join us on KustoCon on November 8th. Then in the news, for those working with Microsoft Defender XDR, be aware that there is a change that was announced a few days ago. And this relates specifically to the initiating process folder path. That's an attribute you will find in many of the Defender tables, like the device process, device registry events, etc. And the change is that they are now actually bringing more consistency to it, because historically in the initiating process path, sometimes as the attribute calls itself, it used to be a path, but very often you did not just see the path, you would also see a file name. So here on the next slide, you see some examples. Before you could have, the file name included, and after the rollout, it will be the full path, including the file name of the initiating process. So yeah, important if you have any detection rules or threat hunting queries that rely on this attribute, please make sure you're aware of this change so that they don't break, or in the worst case, you believe that nothing is happening. Well, there is actually something happening. And all the details, by the way, you find here also in the link. The show notes are prepared, so right after this show, you should have all the links as well, so you don't have to type them off the screen. Good. The next one to highlight, again, in the land of Defender for Endpoint. Here, Bert-Jan recently posted a blog post, and just in case you weren't already familiar with the DeviceTvmInfoGathering table, which actually came up, I would say, almost a year ago. And also Johnny is going to talk a little bit about it later. But take a look there. So if you are interested in, what platform engine or Defender versions you have deployed, historically, we used to apply workarounds like, looking at the Defender MP engine executable from the process table, and we would, strip the version number out of there. But within this table, for example, if the data is right, and Johnny's going to talk a little bit about that, but you should get exact information about the platform, the engine version, the definition updates, but also very interesting, and that's what caught my eye a while ago, is that you also find all the individual ASR, so the attack surface reduction rule configurations. Unfortunately, not the exclusions that you have configured, but at least you can really drill down into the individual ASR rule, whether they are enabled or in audit mode or in block mode. This table also provides information about some of the TLS1 configuration settings. It will help you to identify, for example, if you're running a Windows 10 long-term servicing branch edition of your SKU. So yeah, quite a lot of nice little information that you wouldn't get out of the other tables. So read JohnDCyber's blog, and you will also find, meanwhile, a number of queries when you go to KQLSearch.com, and when you search for the table DeviceTvmInfoGathering, you should see a whole bunch, meanwhile, of interesting KQL queries that might inspire you. Then, hot off the press, yesterday, I'm subscribed to a number of those newsletters, and Rod Trent just shared yesterday that because someone fell out of his session, so he had to do a spontaneous session, and he also shared, and of course, what did Rod Trent talk about? If it's not Copilot, he talks about KQL. For those who don't know him, he's also the one who developed a whole must-learn KQL learning path, including videos, books, training content. And yesterday, he posted and shared his session slides, including demo queries of his session that he presented at the Midwest Management Summit that took place, I believe, last week.
And he was also our first guest at the KQLCafe.
Yeah, indeed. Yeah. Good. Then another thing I stumbled upon, although I have an open question here to the author of this. So if you go here, there's a whole bunch of interesting KQL queries. There's just one thing. When I looked at it, there are interesting use cases, but I was not really sure where the data will come from, because the tables he is addressing in his queries didn't sound too familiar to me. So sometimes I thought, okay, maybe this is Sysmon or whatever. I asked him on GitHub whether he could maybe indicate what the data sources will be, but definitely interesting use cases. So have a look at those as well, and hopefully we can add some more information what log sources he used to develop those queries. Then another, I guess, again, you all should have noticed this, is if you are responsible for a tenant, Microsoft has started their journey of enforcing Azure MFA for various portals. So while in the past you will protect your portal through conditional access, you will specify, okay, if you go to Portal Azure or Intune or any management portal, but now this is already enforced at the portal, no matter what you do. And Microsoft has sent out, I think, a ton of emails to make people aware. Later, early next year, this enforcement will continue to also cover command line, so PowerShell and that sort of things. And my colleague Nicolas Zutter developed a number of queries that might help you to also identify, what users are affected, who is not, etc. So definitely also worth to look into this query if you're dealing with Azure MFA enforcement topics at work or in your own tenant. Another thing I actually came across myself is, this has to do, maybe give you some background. So for those who use Defender for Cloud Apps, you know that, you can bring logs from your proxy, but then with the integration of Defender for Endpoint a couple of years, basically every Defender for Endpoint client is also providing telemetry into Defender for Cloud Apps. So if I go to Amazon.com, Yahoo.com, Google whatsoever, the device network information gets translated into Defender for Cloud Apps, and it will basically translate, okay, if I went to that IP address or domain, it will map it to an appropriate Cloud App SaaS application, for example. Now, historically under the hood, this stream of data was called Win10 endpoint users. And already many years ago, I thought, okay, what about the next Windows version, or what about servers or Linux and Mac? And yes, indeed, since about 2-3 months, we now also have this telemetry coming from Mac OS devices that are onboarded in Defender. So the stream name Windows 10 endpoint users didn't really make sense anymore. And that's why it's now called Defender Managed Endpoints, which of course makes much more sense. Now I came across this because I, in fact, myself had a number of queries that would, limit to this stream, because if you have a log collector or any other data sources in Defender for Cloud Apps, they might have different stream names. So this is for your awareness. If you have the MCAS shadow reporting table attached to any of your queries and you're filtering on the stream name, be aware that that is going to change of value. So in my tenant, it started somewhere from one day to the other, probably due to a backend change. They changed this stream name. The good news, though, is if you work with the API, because those stream names also have a unique API ID, that one remained the same. So it's really just a value and not the unique ID that has changed. Yeah, and with that, I'm done with my news. And I'm very happy again, or we are very happy to welcome our guest, Koos Goossens. And I suggest you take over the screen and introduce yourself.
Yeah, thank you, Alex. And thanks again for having me and giving me the opportunity to share this session with a couple of others, with a couple of other fans of everything KQL, so to speak. So my idea was to do this session tonight on building your security data lake, so to speak, with Sentinel and Azure Data Explorer, because if you ask me, I think that's a match made in Azure. A little bit of a pun, of course, in the title, but I think more and more companies and people are looking into Azure Data Explorer. And I think there are a couple of things, a couple of things I'd like to share in my experience, and maybe things that can help make everybody's life a little bit easier in that regard. So let's kick it off. First of all, a short introduction, perhaps. Like Alex mentioned, my name is Koos Goossens. I'm from the Netherlands, and I work as a Microsoft Cloud and Security Consultant for a company called Wortel, which is a Microsoft service provider. There I help customers setting up the Microsoft security products in their environment, but we also have a managed detection and response service for the smaller companies who don't want to hassle with 24/7 eyes on screen on the security events and such. And I have a little bit of a part-time job where I also help improve our managed detection and response capabilities, where I can help, where I can share the things I learned in the field and vice versa. And that's what I like to do also in my blog, for example. I'm kind of proud that I have my own Microsoft short link, aka.ms/Koos, which will bring me to my Medium page, where I blog about Sentinel, Azure Data Explorer, but also a bunch of Logstash, which I will address tonight as well. And I created a couple of tools with PowerShell and shared them there. And this also led Microsoft to award me the Microsoft MVP title 2 years ago in the security category, which also made me very proud, of course. So when I'm not working on these things, I'm a photographer. I like to smoke some meat on the barbecue. I'm into watches, especially mechanical ones. So I'm kind of jealous, Alex, that you live in Switzerland, nearby all the great vendors. I want to talk about what you're wearing tonight. I see you holding something up in the small corner of my screen, but we'll get to that later. Whenever there's some snow in the Alps, I like to do some snowboarding. Again, Switzerland, Austria. And I'm also into pinball machines. And yes, that is still a thing in 2024. New machines are still being produced, and there are even podcasts and everything, a whole community. I like to tinker with that as well. So that's a bit more about me in my spare time. So I made a small agenda for tonight. First, I want to start off with a short introduction. What is a security data lake, in my opinion? Then I want to move over into some more deep technical stuff regarding Azure Data Explorer, what it is, how it works, and well, why I think you should look into it. Thirdly, how you can create a multi-tiered architecture, if you will, how to combine all the multiple resources together and make it work seamlessly together. I have a couple of other optimizations and tools I'd like to share, and I want to round off with some key takeaways and some additional external resources you could probably pay attention to. There are a lot of demos sprinkled throughout the session, so yeah, I have quite a lot of ground to cover. So, but I asked Johnny in advance if it's okay. 50 to 60 minutes, I guess. We'll dive into these topics. So let's get started. Let me see if my clicker works. That would be fine. Yeah, and again, since I'm a watch nerd, I thought it was fun to apply the watch theme here as well. And since I'm starting with a simple introduction, I thought maybe it was fun to start simple in the watch world as well. And this is a watch probably every watch enthusiast will recognize. It's a Casio F91W. And what the fun thing is about this watch, it is produced since 1989 and sold for $20. And it's still produced and sold up until today for the exact same price. So for some reason, inflation doesn't apply to this Casio watch. And it's quickly became a cult classic among watch enthusiasts. Obama, for example, wore it, but it also got some questionable fame because it appeared to be a very reliable detonation device for explosion devices. And another fun fact, even if it's so cheap, for $20 you can buy one, there are still Chinese knockoffs made as well. So that's also funny, I think, that people are making a profit out of that. Okay, so enough about watches. a security data lake. I already mentioned the term a couple of times. What is a security data lake? Well, if you look at the Microsoft MCRA, Microsoft will tell you that Microsoft Sentinel is a security data lake. And you can even store network logs in there. And when I say security data lake, I'm actually referring to the concept in general. And we're not talking tonight about Azure Data Lake, which is a completely different topic. But I wanted to mention that to get some confusion perhaps out of the way. So Microsoft Sentinel is a security data lake, according to Microsoft. And you can use it to store all kinds of logs, also custom logs and things outside the Microsoft realm. But as we probably here all know in this session is that Microsoft Sentinel is based upon log analytics, and you pay for a certain ingest fee for log analytics, and on top of that you pay this a little bit extra for Sentinel. These prices, by the way, are notated in euros because I just used my local Azure calculator, and these are list price for Western Europe. Obviously, your prices might vary a bit with discounts and everything, but I thought I would keep it simple to use the same price ranges across the whole session, because we'll talk about cost savings later as well. So is it really a good idea to store all these massive amounts of logs, for example, from network appliances into Sentinel with this pricing model? Well, I see customers moving elsewhere because it can very quickly add up. And well, you probably already know where I'm going with this. But before I'll dive into that a little bit deeper, I'd like to address a couple of things regarding the table plans in Sentinel, because the price I mentioned earlier is for analytics tables, but Microsoft Sentinel nowadays has some additional tables as well. So, and this analytics is the default table. That's what Sentinel came with. What is it? 5 years, more than 5 years ago, when it went general available. Microsoft will tell you that analytics tier is for high value data. It's high performance, you have real-time detections, you can build dashboards, all of your tables support it, because yeah, that's the original tier for the tables. You can store data for multiple years. You can extend it into archive, but more on that later. But you pay the standard pricing. So this is both numbers you saw earlier added up, a little over €5 per gigabyte. And if you commit to more ingestion on a daily basis, up to terabytes a day, the price will go down to about €2.5. Again, with archive, you can extend the retention to 12 years, but you have to restore from archive. So that might be a downside when you want to read the data. So basic logs is what Microsoft calls ideal for your medium touch data. It is a tier that was introduced, I don't know exactly 1 or 2 years ago, perhaps even longer. It is still high performance. It comes at a reduced cost, significantly reduced, as you can see here. You can still build dashboards, although queries are not included. So if you're going to build dashboards on basic logs, every time you refresh your dashboard, you will inhibit extra additional costs for the queries. And one other major downside is that you cannot do real-time alerts in Sentinel on it, and that's also why the price is so much lower than analytics. Also, KQL functionality is a little bit crippled. Well, maybe that's too harsh to say. When Basic was introduced, it was really limited KQL functionality. They did improve on that by now, but still you cannot do any advanced joins or such. Or there's a couple of functions you can still not use. And only Basic is only applicable to supported tables. So custom logs are supported and a few others, but not all tables can be transferred into the Basic tier. Another downside is 30 days of retention. This was 8 days, which was really short. Now it is a month, which might be fine for some use cases. And you can also extend it into an archive for up to 12 years. But again, you have to restore it there. And now the auxiliary logs, which are very new. Not sure when they were introduced, a couple of months ago, I believe. It is still in preview. Microsoft will tell you this is ideal for your low-touch data, as they say, with a minimum cost, which is indeed much cheaper again than basic logs, but it's only for your custom logs as of right now. It is less performant than basic and analytics. Again, queries are not included. Also, some limitations in the KQL functionality, and you have the same retention as with basic logs. But even the archive is a little bit restricted as well, up to a year. But I do believe that when Microsoft will go GA on this, perhaps we'll hear more about this during Ignite, then I'll expect that this will get the same retention periods as the other tiers. Then you can still restore, and there is somewhat limited availability. When I created these slides a couple of months ago, it wasn't even available in Western Europe. I noticed that Western Europe is added by now, and I also assume that Microsoft will add additional regions soon as well. But this is again a preview feature. I believe you don't even pay for it right now when you use it, but the price that you see here in the bottom right is the price you are going to pay once it goes GA.
Also good to know, a small note on that is if you ingest now, you won't pay for the cost later on. So you can pocket all you want. And then as soon as it goes GA, then everything newly ingested you pay for, but you won't pay the
So the existing tables you created will never be charged.
Yeah, it's for the ingestion.
Okay, well, there was a nice loophole there to create some massive terabytes of data there. But who knows? I'm not sure if we should really rely on that, right? Who knows what will change in the future? But still, there are, I think, a couple of reasons why you could look into some other options. But before I want to go into that, I want to highlight another thing, which was probably also addressed in one of your earlier sessions. Microsoft already did some effort to bring logs together outside of Sentinel with the introduction of the unified security operations platform. So the Defender XDR product and Microsoft Sentinel are now together in the same portal, which is probably well known by the audience of tonight. But now you have a unified incident queue, for example, in Defender, and also you can use the unified threat hunting experience, which gives you the option to navigate all the data for Defender and Sentinel. So, is this what Microsoft take on a security data lake, the unified security operations platform? Then perhaps. Well, when we look at the Defender data, for example, we still only have 30 days of retention. I believe through API it is extended now, but still the interactive retention is 30 days. And of course, Microsoft will tell you that you can enable a data connector in Sentinel and stream data there and extend the retention there, and also make use of maybe some more advanced use cases that way. But it will become expensive, very soon. And this was actually the initial reason why I looked into ADX a while ago, because I was working for a customer who really needed longer retention for the Defender data and really couldn't afford storing it in Sentinel. And I actually have a calculation of that scenario later in this session. But I became a big fan of it. So I would say consider this to be your ideal security data lake, in my opinion. Use ADX alongside as a companion of Sentinel and Defender XDR. Okay, that's so far for the introduction. Now it's time to dive into the bits and bytes, the nuts and bolts, or as they would say in the watch world, the hairsprings and balance wheels. So let's dive in what ADX has to offer on this regard. A couple of key properties. It is a fully managed service. So you set it up, you see just one single resource in the Azure portal. Microsoft will take care of everything that's on the back end. It supports high-speed data ingestion for various resources. And most importantly, perhaps, and that's why we're here tonight, it supports Custo query language. And Actually, Azure Data Explorer is the granddaddy of Kusto, so to speak. Kusto is still the name of an Azure Data Explorer cluster in when you look at it from an Azure Resource Manager management perspective, for example. And this is where Kusto started. So it's elastic compute and storage, and it can auto scale and handle loads of data for you. And most importantly, it's cost effective. So I mentioned it's fully managed, but let's take a look under the hood what's actually running behind Azure Data Explorer. So it is fully managed. You will see just one icon in your portal, but when you look at your invoice from Microsoft at the end of the month, you will see that you are billed for virtual machines, virtual network storage, some load balancings and gateways, and obviously also some Azure bandwidth if it's applicable. And these are obviously all familiar Azure components, but we don't need to manage them all individually. We just have a Azure Data Explorer cluster to take care of. In regards to storage, you have 100 years of data retention, which is probably enough for most people, I would say. You can apply data compression, which is very effective. When you go into the Azure calculator, Microsoft will propose you a 7x compression, something like that by default. But I've seen up to 15x data compression in the real world with lots of network logs. So that is also already a reason why it's so cost efficient, because you only pay for the data that's actually being stored. You can enable some SSD caching to improve the performance, but I would always recommend to be very careful with that, because if you're needing a lot of cache for lots of data, I think you're building your own log analytics workspace again, and I think it defeats the purpose why you're using Azure Data Explorer in the first place. But you can do it for perhaps several databases or something. So how do we ingest logs into the Azure Data Explorer? Well, we have some native Azure resources with support for ADX, like Event Hub and Cosmos DB, where Azure Data Explorer can retrieve the data from. And we also have some native integrations like Azure Functions, which have a native integration to send data to Azure Data Explorer. And then obviously there are APIs, and then you can create your own log ingestion pipeline with your language of choice. But I think Logstash can be a great option as well, either on a virtual machine or you run it on a container service to your liking. And I think Logstash can be a very valuable asset here to orchestrate logs to Azure Data Explorer, because Microsoft actually has a native output plugin for it. This is a very simple example of a syslog listener on Logstash outputting to a Kusto cluster, where you just provide some credentials for your Kusto cluster. More on this later in the session with some more detailed examples. Within the Azure Data Explorer, you create databases, and each database is separated with RBAC permissions, for example, but also has its own retention period, as you can see here, and its own SSD caching and whatnot. So you can have different retentions and different settings on different databases. And within every database, you have your familiar overview of tables, like you're already familiar with Defender or Sentinel, for example. You can create these tables through the UI with several wizards. But I like to do this from code as well. And that's because I work with a lot of customers where they want to apply infrastructure as code as much as possible. And it's really great that ADX is providing you some options with what they call ADX commands. They look a little bit like Kusto, but I think they're more like SQL perhaps. And you can run them on the cluster to manage your cluster, to create tables, alter schemas, implement parsers, for example. And I'll have more demos and things to show on that later in the session as well. And what this will look like, for example, when you create a table. This is an example of an ADX command, creating a table with the entire schema and the data types, for example. And you also want to create some kind of what they call an ingestion mapping to tell ADX what kind of data is coming in In this case, it's JSON. It's a long line with a lot of data types and references to the destination columns. But what's great is that you can also do some transformation here. So in here, for example, I know a couple of network appliances. They use in their syslog traffic a column named version with an @ sign in front of it. And this is a legal character to use as a column name. So you probably want to do something like, as Microsoft does with their agents, for example, use an ls_ prefix as an example. It's great that you can create these ADX commands, but I was thinking when I need to construct these commands from scratch for all my log sources I want to onboard, I can probably make this a little bit easier. And that's why I created a little tool with PowerShell, and I want to demo that to you. And this can make your life a little bit easier. So in here is a GitHub repository. Perhaps we can fork it to the KQLCafe repo later, but I'll make sure that it's shared after the session. Here you see a log sample coming from a vendor, or in this case, generated by Logstash itself. This is just a syslog message, unparsed, with a couple of additional columns. And when we send this to ADX, we need to create a schema and an ingestion mapping for it. And that's why I created a little script, which I call get ADX command. And I refer to a sample directory with all kinds of log samples in there in JSON format. And it will spit out the ADX commands for me. It will analyze the log samples. It will look at how many columns are in there. And it will also eliminate illegal characters like the @ sign we saw before. And it will fully automatically create this purple text for you, which you can just copy and paste in your ADX cluster. And it will even take into account those optional transformations like ls version, for example. And this can help you set things up the first time, or you can even incorporate it into an automated pipeline if you like. But I also want to address parsing. I think this is top of mind for at least Alex and Johnny in their daily work, and probably with a lot of other people in the audience as well. We have several ways to parse data, both in Sentinel and ADX. In Sentinel, parse on query is a very, very common thing to do. In this case, you're looking at a parser from a proxy by Symantec. This parser came from GitHub, from the Microsoft Azure GitHub repository. You can just copy and paste this in Sentinel. You can run it, and as you can see at the top, it's looking at proxy_cl, and it will parse all the data in an asym structure in nice separated columns. You can save this as a function, and then you don't need to hassle with the entire parser every time. But still, when you want to look for something in your logs, you're parsing all the data every time you are querying it. And this can be very problematic from a performance standpoint, especially with these massive amounts of data from proxies and firewalls. Your query will time out because your parser took a lot of a big hit on the performance when you were looking for the logs. So ideally, you want to parse on ingest. With Sentinel, you could look into creating an elaborate transform KQL in your data collection rule to parse the data when it comes in. But there are some major downsides with that. Because, for example, the parse key value function, for example, isn't allowed in a data collection rule. I don't understand why that is. Perhaps has something to do with backend performance by Microsoft. But they only allow a couple of functions inside a data collection rule. Also, a union, for example, is not allowed, which isn't ideal when you create some complex parsers. So parsing on ingest in Sentinel is hard. And why do I bring this up? Because it's very flexible in Azure Data Explorer. This screenshot I showed earlier, if you looked really closely, you also could already notice that I have a proxy CL similar to Sentinel in the example earlier, but also proxy CL raw variant. And why is that? Well, with Azure Data Explorer, you could create a separate table where the raw logs come in an unparsed manner. You create a separate table with the schema with your desired output as how you would actually want the data to look like. So you create a raw table and you create a non-raw, a regular table with your actual, in this case, device network events from Defender, for example. You create a separate parser and you store that in what ADX calls a expand function. The expand function can create as complex as you would like KQL query, looking at the raw data and parsing the data for you. And an update policy is something you can create which will actually trigger every time logs that came in the raw table. It will trigger the function, and the output and the result of the function will be stored in your destination table. And this way, you don't need to parse on query every time because the data is already parsed for you by ADX in the backend and stored neatly in the destination table. You might think that I missed a spot here because 1, 2, 3, 4, 5. Well, I actually skipped the ingestion mapping, which is also, of course, needed for the original raw table. So when we look at the ADX commands perspective, as I've shown earlier, with the 2 commands, you need to add 3 more things by code to create not only a raw table for device events, for example, network events, a destination table without the raw, a function containing your entire custo parser, and lastly, a update policy, which will trigger the function when new data comes in. And the great thing of this, you can obviously incorporate this into your pipeline. So whenever you want to update your parser or when a schema change is happening, you can just change the ADX command, and by deploying it from a pipeline perspective to ADX, you can update it automatically from code, for example. And this is an example of one of my customers doing it exactly in that way for all kinds of databases they use and refer to some custo files on the repository. And these are automatically applied to the databases every time we make a change that way. But deploying it from code, especially for the Defender XDR data, for example, and this is something I mentioned earlier, can be quite complex. And I'll dig into that later from a code perspective, why that could be quite complex. But from the Defender side, it's very easy to store it in Sentinel. We just enable a data connector, and the data is extended into Sentinel. But again, this is very pricey. How pricey, I'll show later in a practice example. How can we store the same data in ADX, you'd ask? Well, we don't use a data connector. We use the streaming API by Defender. And with the streaming API, we can send data into the event hub namespace we created. And since event hub namespaces has native integration of ADX, we can get the data in ADX that way. And if we have a very big environment, we might need several event hub namespaces to make sure that all the data is processed in time. But setting everything up like this, the event hub namespace, creating the streaming API, creating all the different tables for Defender and Azure Data Explorer with the proper schemas, with the parsers, with everything in place, got quite complex. So when I looked into this for a customer, I started automating all these steps from the start. And this is why I think a year ago introduced a PowerShell tool I called Archiver, just a little joke and a nod to the 80s and 90s with some ASCII art. And this can do this completely automatic for you. And I'd like to show you shortly how you could leverage this. When you run the Archiver script, you can provide which Defender XDR tables you'd like to extend into ADX. You cannot provide this parameter, and then all tables are extended. Otherwise, you only provide the tables you'd like to extend. In this case, I used a subset of all tables available. So what the tool will do, it will actually query the hunting API to retrieve the schemas of all these tables for you. And what it will do at the end, it will generate an ADX script for you. And within the ADX script, everything is there to set up ADX automatically. Next, it will calculate how much event hubs are probably needed to do all the load coming from this environment. And in this case, I decided to do 12 tables, so I need 12 event hubs. And by the calculation it did, by calculating the number of events per second, we know that we need 2 event hub namespaces, and we need to divide the 12 event hubs accordingly. And my script also takes into account that multiple high load tables, like the device process events, for example, and device network events are not on the same event hub namespace. So it uses a round robin mechanism to divide it as evenly as possible. So now we have 2 event hub namespaces. We can deploy them to Azure. It will create everything in there automatically. And at the end, once it is deployed, it will tell you the resource ID from the event hub, and it will tell you, use this resource ID and these table names for setting up the streaming API in Defender. So now you go into the Defender portal to streaming API, and you only have to paste the resource ID here for each particular table listed in purple above. And the same goes for the second event hub.
Oh, so we have a question.
Yeah,
exactly on this thing. So we got a question. Can you capture TVM tables? Meaning, are the TVM tables also exposed through the streaming API? I guess that will be a requirement, right?
Yeah, that's true. That's a good question. I don't know from the top of my head. When you go into the Defender portal and you go to the streaming API, there are all the checkboxes for each and every table. I am not 100% sure right now if TVM is in that list.
Okay, and then there's
if it is in the list, then you can use it. Yes. If not, then
not
Microsoft does not provide in a way. Sorry, Johnny?
It's not in the streaming API bits yet.
Okay. That's too bad.
Yeah, and then there's a question. For the event hubs, does it define the partitions required and throughput units? Yeah.
Yes.
Cool.
Yes, it does everything automatically. So the partition is taken care of. The throughput units is roughly based on the events per second from Defender, but you can all opt to enable auto scaling on the event hub namespaces so that the throughput units scale accordingly. But since there is a limit on the amount of throughput units, especially for the lower tiered event hub namespaces, that is exactly the reason why I split them up over multiple different event hub namespaces, because 40, I believe, is the limit, and you don't want to go past that, because then you'll lose logs. You could also opt for a premium or a dedicated event hub namespace. Then you can put everything in one, but then will probably cost you so much that it might defeat the purpose again. But an exact calculation on this, I will share in a later slide in a second.
Cool.
Any other questions?
No. I don't think so. And if yes, okay, I'll interrupt you again.
Yeah. Great. I always like to hear great questions. So in the end, after ADX cluster is deployed, it will also automatically create the data connections for you to retrieve the data from the event hub. And it obviously also needs a system assigned managed identity to do so. And also the permissions for that are also automatically applied. So this is just a one-time setup. And you can find it on my GitHub page as Microsoft 365 Defender-ADX, or you can go to my short link and you'll find a blog on this as well with all the additional explanation. You can try it out in your lab or in your production environment, and I think it's a very useful way to extend this logging into ADX. Obviously, it's slower than in Defender. That is as to be expected. It's also slower than when you would look up data in Sentinel, but the price is so much lower. And again, I'll have an example on that later. But it depends on what you're using it for. But for hunting, for example, where you don't really need to have an instant result, I think it's fine.
One question for myself. So, first of all, this is great because I believe you had blogged about this earlier before you created this whole PowerShell script.
Yeah.
And if I'm honest, I was like, okay, great concept, great idea, unmanageable. Especially, I'm a type of person like, okay, I know my customer, the skills they have. So do I really want to implement something like that? So this is already a big leap forward. What now comes to my mind is, okay, I run this on day one. Now, as we all know, now and then Microsoft is extending the existing schema. So could I just rerun the script and if in device network events like we saw recently, we have some new attributes, it will just update it, or?
Yeah, 100%. Yes.
Cool.
Yeah.
Yeah.
So you can, since all the deployments are incremental, you can actually just rerun it as much time as you'd like. The deployments are much faster, of course, the second time around, but it will redo the querying of the hunting API, retrieving the schemas, generating an ADX script for you. If the only need is to keep the schemas up to date, I would probably advise you to comment out a lot of stuff in this PowerShell script and make it part of an automated pipeline, for example. Even if you have the need to use ADX anyway, and as I showed earlier, create some custo files where a lot of schemas are managed in a centralized way, then I would say only use the part of the PowerShell script where it will retrieve the schema, save a custo file, and then deploy the custo file together with the rest of your custo files you have in your repository, for example. Or do it manually.
Yeah.
That answer your question, Alex?
Yes, definitely. Yeah.
But still, I sometimes jokingly say it's a lot of plumbing. So that's always the case with custom logs, I believe, with Sentinel, log forwarders, agents, firewall changes. How do you do that over VPN, public internet? There are a lot of design choices there. And all the additional plumbing comes with a lot of overhead, right? So who's going to manage that? Who's going to monitor it? Who's going to update it, backup it, etc., etc.? And that is still a very valid concern when it comes to ADX. It is not as greatly integrated in the whole Sentinel experience. And that's also something I mentioned later in the session. But there are a couple of things I will also share which can make your life a little bit easier, especially from a security, a SOC analyst perspective, for example, to have a seamless way to actually retrieve the data without going into multiple different user interfaces. But more on that later. So this was the cost the comparison I did earlier with the tables. So if we put ADX alongside, I would say ADX is also fit for medium to low touch data, similar to basic and auxiliary. It comes with minimal cost. Your queries are included this time because, well, you already have the cluster running. You can have full KQL, not only in your functions, your parsers, but also when you query. There are no limitations. You have, well, virtually unlimited retention, right? 100 years, I would call that unlimited. But again, you can still cannot do any real-time alerts on it as with analytic rules in Sentinel. I saw some customer create some custom stuff, some Azure functions or logic apps, which were looking into ADX data and determining if a security incident should be raised and then creating an incident in Sentinel. But I think it's not really the main reason why you would do that. I think you're recreating a Sentinel product as a whole. And again, a lot of additional plumbing and overhead. I'm not sure if that's really why you would go the ADX route. Also, a downside is that Azure Diagnostic Logs cannot yet be natively streamed to Azure Data Explorer. So when you go into Azure, you can stream to storage, to Log Analytics, to Sentinel, but not natively to ADX. You can stream to Event Hub, and you could set up a similar pipeline as with Defender, but it's not a native integration, which is too bad. Who knows, that will come in the future. It is high performance. Could be high performance, but it will cost you. Again, I would advise against that. And Alex, as I mentioned, additional overheads. It's a very valid concern. But when we look at the pricing, and I did a Azure calculator outside of this session, and I took 100 gigs a day ingestion, my pricing came up to 12 cents per gigabyte. And you can even go as low if you ingest, for example, a terabyte a day, which larger companies do regularly, you can go as low as 3 cents per gigabyte. And I think it's funny that the 12 cents exactly aligns with auxiliary logs, because I think Microsoft is actively looking at auxiliary logs as an alternative to companies that are moving away from Sentinel, which is a very valid point. And I think they want companies to stay in Sentinel, especially with, well, who knows, Copilot for security in mind, for example, later along the road. But again, ADX is still so much cheaper and so much situations that you might have a use case for it. I mentioned a couple of times a cost comparison. This was a customer I did it for initially. They had 160,000 devices and for quite a large organization, and they wanted to stream all 19 tables. Well, all 19 tables as of that moment, well, when I was working on it. And they generate 25 billion messages a day, which is about 69 terabytes a month, which if you would enable the data connector in Sentinel and you do the math, even if you have the highest commitment tier in Sentinel or the highest discounts, you still pay more than €2 per gigabyte, and they would have ended up with a bill of 169,000 euros a month, which was obviously not feasible for them. Doing exactly the same with EventHub namespaces. In this case, they had 4 EventHub namespaces from the top of my head, with also not the basic ADX cluster anymore to keep up with all the data coming in. But they ended up together for the whole setup for 7,500 euros a month for, well, it's not the same. Again, it is slower, but at least now they had the data for up to a year, so they can look at it, they can show auditors that they have the logs, etc.
But it's slower because of the VMs attached, or by definition slower?
It's slower because of the storage beneath it, because ADX uses some intelligent software to distribute your data on blob storage. And blob storage is not as quick as log analytics, for example. And that is why I mentioned earlier, you could enable SSDs on the logs. But what are you going to do if you really generate 69 terabytes a month in an environment, and you want to use SSD cache on that? You can calculate how much terabytes of SSD you would need if you want 2-3 months of data cached, and then it could be as fast, perhaps, well, it will come closer to log analytics, but the price will go back through the roof, of course. And for the first 30 days, you don't need the cache because the data is already there in Defender. So if you need fast response on short time span data, go to the Defender portal. That's perfect for it. Okay, so I thought it was a fun analogy with the watches again, with all the different layers of complexity, but still work together, right? Just as with a watch, it's also layered. The parts on top are moving very fast, like Sentinel, and the deeper you go, the slower it gets. But altogether, they still share a similar function, and that's what I like to achieve here with ADX alongside Sentinel. And let's just for fun throw in a blob storage account in here as well, because I see them used regularly for regulatory compliance requirements, for example. A lot of Azure diagnostic logs land on storage accounts, but how can you retrieve the data from there? And how can you retrieve the data from Azure Data Explorer and Sentinel all together? And that's what I want to zoom in right now. So again, I would say use Sentinel for real-time analytics. And you could use ADX for triage and hunting, for example, and you can use your blob storages for compliance and perhaps even forensics, if you will. And your agents generating logs can send their logs to Sentinel, for example. You perhaps have some event hubs, for example, sending some data to ADX. And your Azure diagnostic logs, again, might land in either Sentinel and or blob storage, for example. But what about those network logs I mentioned earlier? And I also mentioned earlier, Logstash can be a very valid solution there, because the great thing of Logstash is you can send it everywhere. You can send it to Blob, ADX, Sentinel, and you can even orchestrate what goes where. More on that later. And what's also great is that Logstash has a lot of input plugins, for example, to get data out of databases, for example, or even ingest files in general and send them somewhere. And that's why I think Logstash can be a very valid orchestrator, if you will. And the configuration I showed earlier, this was a simple example, but if we can look at a more elaborate thing like this is an example of how you could collect syslog messages. And depending on the source, we could say, okay, if the source is 10.0.0.4, I know it's a Palo Alto, we want those logs into Sentinel, for example. But if it comes from our semantic proxy, I want to send it to ADX. And there are a lot of different ways to do this. For example, within the filter of Logstash, you could say, if a log is a raw log, just raw traffic log, send it to ADX. But if it's a security alert, because my Palo Alto has some threat intelligence module, for example, then I want that message sent to Sentinel, for example. So you can do some very creative stuff this way. And when you look further down in the output section, we use the same tags applied in the filter steps. Why is my clicker not working? Use it to send it to different output destination in this case. So use both Sentinel and ADX. Before I show you that, how it works in practice, go back to this overview again and tell you a little bit about how you could retrieve those logs easily. So the security analyst might have the need to look at both Sentinel and ADX. And even the security analyst might, for, I don't know, forensic reasons, want to look at the logs as well. And there's also a neat trick I'm going to show you soon that you can use ADX to look into those blob storages for you. It's called an external table, and I'll demo it in a second. And it makes your life a lot easier finding something on those blob storages by using KQL, actually. Your threat hunters might only need access to Azure Data Explorer. Your auditors might also use Azure Data Explorer to, again, look at some compliance logs to make sure that, that the logs are in place. And with the RBAC model on the databases, you can do exactly that. So into the next demo, where I can show you all this great stuff. So in this example, I'm going to log into a couple of Logstash instances I created beforehand. Why is the video not running? No, it is. Okay. So I'm going to open up an SSH session. Don't mind the ASCII art that will pop up because that's for a different community where I gave this session earlier. So it might look familiar to some. But this is a Ubuntu machine. I prepared by installing Logstash on. When I open up the Logstash configuration in the Logstash directory, you'll see a similar setup as on the slide earlier. So we have an input, which is syslog in this case, but you can obviously add multiple inputs, of course. The filter, which will do a different tag based on the source IP. And then in my output, I have a Sentinel data collection rule-based ingestion with an immutable ID and an app ID and a secret in there. You cannot use it anymore. The secret is removed, of course. And also a custo output. And when I run Logstash, you'll see that it will do a lot of stuff. This is scary at first when you're not familiar with Logstash, but that's how it works. But you'll see that it opened up a UDP listener on 5514 because 514 is in use by default. So I used a different port. And I open up a new tab and I log into the same box again because I want to show you what happens when I use when I send some syslog traffic there. And I use a basic logger command. And with a logger command, we can emulate syslog. And we send it to 10.0.0.4, which is the IP address of this box. And I just use a basic example of a syslog proxy message. And you can see here that this is indeed the IP address of the machine. And when I switch back to Logstash, we already see that logs were posted into Log Analytics because it uses the Log Analytics output plugin to send data into Sentinel. Now I log into a second box. I prepared. This has nothing really installed on it, only the fancy message of the day. And I do the same thing by sending a syslog message. I'm also sending it to 10.0.0.4. That's my Logstash instance. In this case, I'm using the same syslog message, but that's not really the point. And when I open up the ifconfig, you'll see that this is actually a different machine. This is running on 10.0.0.6. And in the Logstash configuration, we told it that it should send everything to custo when it comes from that IP address, and it did. So you also see that it works a little bit differently, uses a temporary file to store it first and then send it to custo. But when we go into Sentinel and look at the proxy logs, we'll also see that the additional fields which we added in the filter were actually added to the log. So here we can see the host. This is coming from 10.0.0.4. The host name is Logstash01. This is still unparsed data. More on that later. And when we go into ADX, I can show you that we have some data there as well. So I created a database I called Network Archive, and in there is a proxy CL raw table. When I run the query in the last hour, we'll see that we have logs there as well, coming from 10.0.0.6. So this is a way how you could split and send logs to different destinations, for example, for on-prem networking. And again, this was the raw table. I also set the function and the update policy beforehand. And when I look at the regular table, we see when we look at the get schema, we see the entire schema of the original logs. And that means we can look for a source IP, for example, according to the ASIM schemas. And in here, you'll find all the parsed data already with the status messages, web categories, etc. And we didn't have to do anything on query. This was already parsed for us when it was stored. Another trick I want to show you is how you could make your life a little bit easier of the SOC analyst. So they probably will work from security.microsoft.com a lot of the times. And you can actually look for the data in ADX from here as well. It's I'm not sure if a well-kept secret, but it's something not a lot of people know. So this is, for example, my device events. We're all familiar with it, right? This is just regular data. But I also have an ADX underscore device events. And this is actually querying the data, the same data in ADX for me. And of course, it takes a little bit longer because it's slower. That's a fact. But we get the same results, in this case, from ADX without leaving the UI. How does this work? Well, I stored a function, a workspace function in Sentinel to make this happen. And inside the ADX underscore device events, there's actually an ADX function referring to my table. And what's funny is that this was created by my PowerShell script as well. So it has an option to deploy these workspace functions for you. And because the Sentinel workspace is onboarded into the unified security operations platform, that's why we can use the Sentinel functions in Defender. But we can also use it natively like this. So this ADX function is referring to the proxy CL logs I showed earlier in ADX. And in this way, we can look for a source IP example, the example I showed earlier, straight into ADX.
Quick question. How does the permission work here?
This permission is user context. So this user has the permissions to query data in ADX.
Oh, cool.
Yeah. So this URL is actually triggering an API in the back, and that will check if your token has permissions.
Okay. Yeah. Yeah. No, I mean, I've heard, to be honest, I've heard about this is possible. I've been doing external data things, and there, if you had private data, you have to embed your shared key and all that stuff.
It's
that
not the
again,
case here.
becomes plumbing. But this is super cool. So you can basically have a proper RBAC solution in your Azure Data Explorer, aligned to the roles of your analysts and engineers. Okay. Yeah. Super cool. Yeah.
And I can maybe show outside of this session later, but if you go into dataexplorer.azure.com, you even have a separate UI for Data Explorer. And what's fun is, what I used in the past, if you need to prove an auditor that you have certain logs, or you want to maybe grant access to the networking team to their network logs in ADX, you don't even need to have them a reader access on the ADX cluster. You can just grant them query permissions on the database. And if they just go to dataexplorer.azure.com, they can connect to that database and query it without even having to open up the Azure portal or need any Azure permissions altogether.
Nice.
So that's what the Custo team already took care of. Then I mentioned the blob storage earlier. I want to show you the trick. In this case, I have set up a key vault with some diagnostic logs storing in my blob storage. This is all familiar stuff, perhaps. And when I go into the storage account and I go into my containers section, you'll see something that's probably also familiar with many. You have to drill down an endless amount of containers because the entire resource ID is stored in subcontainers. Drill down to the month, to the date, to the hour, to the minute, and then eventually we'll end up with a JSON file containing all the logs of that minute. I can download the JSON file and I can open up in VS Code, but what can we really do with it, right? How can we actually find something in here? And how can we find something across maybe a larger time span, for example? Well, I also created a script to help you create what ADX calls an external command. It's a little bit similar like the PowerShell script I showed at the beginning for generating ADX commands. But in this case, we provide a specific subscription ID, a specific storage account name, and a temporary folder, in this case on my Mac, on my desktop, to store one of the JSON files from that blob container. And it will connect to the blob, it will download one of the JSONs, pull in the schema, and generate the ADX command for you, which you can just run the purple text in ADX. I will do that in a second. And this will set up the external table for you in ADX. And this is only one time, of course. So when we run this command, we have now created an audit event external table. You can even find it in the subfolder audit event. And it uses a different notation because you actually have to refer to an external table this time called audit event. And what's great, when I run the custo, I get all the logs from the storage account, and I can custo and filter, use all my favorite custo statements to drill down to what I actually want to know from those logs. Obviously, this is also not your fastest way to drill through terabytes of data, but if you know a certain time frame where you want to look at, or again, from the auditor perspective, something that's a year old or 3 years old, you can prove that the logs are there in a very easy way. One of the downsides actually is that the external table function is not yet available in the Defender portal. So we cannot do the same trick with the ADX function as I showed earlier and use it for an external table. So you really have to go into the dataexplorer.azure.com or the portal.azure.com interface. And regarding the slowness of the data, that's also not much of an issue in most cases, because when you go into dataexplorer.azure.com, you can even define your query timeout. So normally we are used to a timeout of a couple of minutes when we're using Sentinel or Defender. Now you're running your own custo cluster. So it's your resources. You can put the timeout in an hour if you'd like, and then the query takes an hour if it needs to gather the data. And that's also an upside when you're handling some larger data sets. Okay. I thought this was just a fun animation because I think it's nice that all these complex parts like ADX, event hubs, all work so seamlessly together from one place. And I thought I had to put in this animation because I really like this one. It's a class example of how complex watch things can go. And I thought it was a fun to show you the other hand of the spectrum compared to the Casio at the beginning, since we're now at the ending of the session. For the watch lovers in here, I don't know, Alex, you know GG LeCoultre?
To be super honest, no, but I like the animation, and I especially like
I
how
thought you
building the watch story into here. Yeah.
Okay.
Because
nice.
it really resembles. Yeah, I mean it's complex, but I would I know a few people build watches. So if you're a specialist, you can build beautiful things.
Yeah. And what's funny is about these complex things, people who are not familiar with watches, all mechanical, and what you see here rotating around this axis is actually what they call a tourbillon. It's actually a mechanism used to eliminate the negative effects of gravity on the precision of the timekeeping. And it also has a calendar with perpetual calendars, what they call. So it knows leap years and how much days are in a month. And I think it's mind-boggling that they can do that with just cogs and wheels and mechanical stuff, create something complex. So I thought it was fun to put in there as a completely other side of the world compared to the Casio. So one more thing I would like to address, some additional tools. One tool, because I think it is also one of the best kept secrets, is a workspace transformation. And I know you had a session earlier on KQLCafe where this was addressed. but I want to show you something that can make it maybe perhaps a little bit easier to set up. For those who don't know, a lot of Microsoft tables provide the ability to create a transformation on the Microsoft table itself. Not all tables are supported, but luckily mostly are by now, especially the diagnostic table ones. And this gives you the opportunity to transform your data while it is coming in that Microsoft table. And you can even have multiple different transformations. So for example, you could say, for example, if you're interested in only the delete actions on a blob container, you can throw away all the other events like read and traverse folder and read attribute and all those kind of things, and only keep the delete actions and send it in your analytics table for, I don't know, an analytic rule perhaps to trigger on. With a second transformation, you could say, okay, keep all the original logs, but send it to a basic table, for example, to a second table. So at least I have the data if I need it, but then I don't pay unnecessary amounts of money for all the different logs I'm not needing for analytics perspective. But the thing is, when you create a transformation in the portal, a data collection rule will be created in the backend in Azure with a specific kind called a workspace transform. And this is tied to your workspace afterwards. And within the data collection rule, you'll see multiple streams for every transformation that you've added. In this case, the AAD non-interactive user sign-in logs table we're all familiar with. In this case, I decided to project away the conditional access policies column altogether and saves 75% of data. And in my opinion, when I really need those logs, I can use the Entra ID interface to look at them for the last 30 days. And I also have the sign-in logs with the same information. This is not much needed by this particular security department. So they wanted to throw it away to save some money. An additional Sorry, Alex?
If I can give an input, I mean, we do this all the time, and especially if you have customers who have a lot of CA policies, this can really add up. So this is always our magic thing, how we can make customers smile that have a big bill in Sentinel.
Yeah, it's a low-hanging fruit, so to speak, right? And every row in this table contains all the conditional access policies. It's really ridiculous sometimes. So I see the decrease of 75-80% in some cases. But you can still keep the original logs in a separate table, in this case a custom table, which you can apply a basic tier on, for example, and at least you have the data somewhere. But the thing is, when you click this all together in the Azure portal, you eventually add up with a quite elaborate data collection rule. And I also know that customers, especially the larger customers, really like infrastructure as code to deploy the data collection rules in their workspace and manage everything from a code perspective. But how can I really ask a SOC analyst to update a data collection rule which is so complex like this, because I want to manipulate the data that's coming in, especially when I'm referring to custom tables. Those tables need to be deployed somewhere as well. They have their own tier. In this case, for example, you see that this is a basic table with 180 days of retention. It's probably not feasible to ask for a SOC engineer to implement updates on the RM side. And this is actually why I came up with the idea to create a tool for that as well, where I just provide a simple YAML formatted file per table, and I store that in the code repository. In this case, my AAD non-interactive sign-in logs with a specific transform. I say basic enabled true because I want to in parallel store the logs in a basic log table, and I just use a basic transform there without any transformation. By going through all these YAML files, I can construct the data collection rule automatically and deploy everything you've seen in the previous slide was an automatically generated data collection rule. And I thought it was fun to call the tool splitter because it's splitting up logs, right? Like an axe. So what it will do, it will go through all of these YAML files like you see here. It'll process all of them. Will determine if a basic table is needed. If it's needed, it will automatically retrieve the table header, so the schema of the original table, so that the basic table has the same schema, of course. And then it will deploy everything for you automatically. And in this case, it's very easy to update the YAML files later on if you'd like. And you can obviously also do this inside a pipeline. Here you can see an example of Splitter running in a pipeline. And the SOC analyst can do a very easy pull request on the YAML files if they need to update the transformation without having to know how the complex data collection rules in back.
Okay. We have a question.
Yes.
Maybe we have to fix a misunderstanding. So the question is, okay, if removing the CA table, so let me try to clarify and Koos will jump in. So we're not removing, the trick of removing the conditional access information in the signing logs is that we're not removing a table, we're just getting rid of some attributes. Because if you look into the Entra ID signing logs table, you will find on every record, you will basically find an array where it basically lists all conditional access policies that you have in your Entra ID, and it will say whether it was actually applied or not, and and if it was applied, whether what was it a success or a block or a grant and whatsoever. Now, because there's no big value in that, unless you are specifically doing conditional access troubleshooting, the amount of data, especially if you have many conditional access policies, which is a topic for itself to discuss.
Yeah, that's true.
Why you would have 80 or 40, but there might be valid reasons depending on whatever use case was defined or historically wrong. But the idea is, we're not deleting an entire table. We're just, say, go away this conditional access policies attribute.
Yeah, I have some examples and calculations on this on my blog as well. So aka.ms/Koos, another shameless plug. Sorry, Jenny and Alex, but I refer to, because I actually didn't find this out myself. I refer to a blog of a different person in the community. I don't know his name from the top of my head, but you're probably familiar with the blog as well, Alex. He came up with this idea, and I just created a tool around it to make it a little bit easier to manage these kinds of transformations. Okay, this brings us to the end of my session. But before we screw down the case back, so to speak, and end it, I'd like to summarize a couple of key takeaways. So I would say be careful with high volume logs and the cost. This is an obvious one. You're probably all familiar with that. Multiple more affordable tiers in Sentinel have their limitations. And ADX, I think, can provide a low cost alternative. But as we saw, it requires additional setup and monitoring. And we also don't know for sure what will happen in the future when Copilot for security really becomes well, should I say this, working proposition? I don't know. I don't want to be so harsh on Copilot for security, but there are some downsides and some challenges there. And again, I am sure Microsoft will solve those, and it will be, the concept is already great, and it will probably end up being a great solution as well. But what about Copilot accessing ADX data? It's unsure for now. So I think that's also why Microsoft is also pushing in parallel to maybe keep your data in Sentinel. Auxiliary logs, therefore, might be a great third option. Also, make sure to check out workspace transformations in general. And I would say it's also nice to search through your blobs with ADX, as I mentioned earlier, with the external tables. And I would say that Logstash proves to be a Swiss Army knife once again. Another pun to Switzerland, Alex. I wasn't aware of this before I started. But I called Logstash a Swiss Army knife multiple times on my blog already, and it's really versatile and flexible. So lastly, again, I already mentioned a couple of times. Sorry for one logo in the top right. I forgot to remove. Sorry for that. Well, we're all in for the community, right? So I actually created this GitHub page, and the link is also down, but it's no secret that I spoke at this event and gave this session there. Maybe we can fork this repo to the KQLCafe one as well, or otherwise you can just visit it here. So this is the repo with everything I showed you today. The YAML transformations, the scripts, the ADX commands generation, the sample files, everything is there, and you can try it out yourself. The Defender Archiver stuff is in a separate repository, but you can find that when you visit my blog. I also blogged about passwords passionately, because I think passwords are used still too often, with service principles, I mean. So that's also why I, with a fellow MVP, created a passwordless experience for Logstash. I called Rotator, also with some ASCII art, of course, and some other tools you can find on my blog. And so far for the shameless plug on my content. But I hope everybody enjoyed it, and I think it's maybe time to look at some final questions, I guess.
Yeah, this was super great. I'm super excited. I have to. I mean, I knew some of the stuff there, but I definitely gonna revisit some of it. Looks like you make some big improvement, simplification. Yeah, really super cool. I personally really enjoyed this 1.5 hour. Yeah,
that's great. That at least somebody, somebody learned something. That's great, Alex. No, thank you.
So the thing is, with this content, it's always changing, and it's also based on the use case, because you can use your data in several ways. Like you said, you have several tiers of data. Microsoft nowadays calls it primary and secondary data. Primary for your SIEM use cases, secondary for the rest of the data. So that's
of course, that's also why I'm mentioning it. That is not a silver bullet to all your problems, but at least something you could consider using alongside, I would say.
There's a question asking, do you have a blog video on how you did do the pipeline with Splitter?
Yes, you can find it in the repository, actually. So the actual pipeline you saw running in the GIF earlier in the slide is inside the repository. I'll put it in chat or add it in the show notes. I'm not sure what the easiest route is, but I'll post it in chat anyway. That's not a problem.
Yeah, I usually create a show note, so I'll definitely catch up with you after the session the coming days, so you can bring all your blog posts and everything I should bring in here. So because on KQL.com, we also want people that can go back, not just to watch the video, but also find all the links. Etc. There's another question. Any plans to continue alongside looking at the same functionality integrated with Fabric? Seems like a big push from Microsoft there.
I'm not really sure what the underlying question is. So store the data in Fabric from Logstash then, or retrieve data from Fabric with ADX? I don't know.
Yeah, maybe if
I'm not an expert on Fabric, so excuse me if I'm asking stupid questions. But
no,
instead of ADX, okay.
Instead of ADX, indeed.
Yeah, I don't know, to be honest. I have not looked into Fabric myself. I'm actually not really that big of a data expert. I became a little bit of an ADX expert along the way. So who knows? I need to look into Fabric in the future. I'm not really sure if it has the same use cases. Can we use Kusto on Fabric? I don't know. Isn't it used for different scenarios? I don't know.
I'm not a data expert myself also, but I see there is a big push for Microsoft to sort of like any source within an organization to have only a single existence, and thereby they say, Fabric is the solution for all of these in the future, leveraging Copilot and everything alongside all these transformations, CTLs and everything. So
could be. And obviously we don't know what Microsoft has in store for us in the next couple of, especially with Ignite coming up, and who knows afterwards. Who knows, they will announce a completely different solution for logging pipelines, because they also see the problem with Copilot, for example, that they don't want the data scattered around in all kinds of different containers.
Good. Let me see if there's more questions.
Congratulations, Alexander.
Okay, good. Yeah, we'll definitely make sure to put up the recording soon. I already know that I'm gonna tell some people to look for an expiring recording. Yeah, and if you feel like we didn't answer your question, you'll find aka/Koos also on Twitter, I guess, or
Twitter or X, or what is it called nowadays? I'm not that active on Twitter. Oh yeah, sorry. I also saw the blog post, Johnny. Sorry, I'll remove this one.
It's okay.
We send at the same time. Yeah. Okay. Glad you liked it.
Cool. Yeah, again, many thanks. Looks like you have to come back.
Sure, anytime.
Yeah. And then...
it's also fun that somebody noticed the transformer in my backdrop. So transformer shout out to Gabor who mentioned it. It's nice. Okay, no, thanks for having me. And again, I would like to come back sometime. So enjoy the rest of your evening, or morning, or day, or wherever you are.
Yeah. So then again, Koos, many thanks, and we wrap it up with some quick updates because we want to be mindful of time. So let me share the rest. So what did you do with KQL this month? I'm gonna allow myself to rush a little bit through so that we don't overrun too much. I was inspired by an article that I found where there was a potential attack where the attacker would misuse the scan type tree file to basically find out whether there's a Defender enumeration. And within my GitHub repository, you will find not only the query, but also the blog post I'm referring to. So I thought, okay, this is an interesting detection. So, I mean, if someone would manually do that, not a problem. But if you have multiple, that's why I here exclude where count for you to customize depending on your detection requirements and what's normal in your environment. But usually I would say, if you have something above 1, that's rather unusual because then someone might be trying to, go through a system and find whether a folder is protected or not, or excluded by Defender. That's the whole trick. I myself was also aware of the check exclusion parameter, but then had to check with the guys who actually developed or not this query, because that's what I did, but let me quickly go there to explain it a little bit better. Okay, I have to share I'm just going to share my whole screen. Okay, so here we have the query, and what they had, this was the blog post. So what they're basically, explaining that you can use npcmd-run, which is a command line tool from Defender to identify exclusions. Now, I extended this with check exclusion because that's also an option that you can use. But they said, yeah, thanks, Alex. But the whole idea, and there I agree, the whole idea of this one was this runs in normal user space. So it doesn't require any privileged permissions. While for this one, the check exclusion, depending on how you have configured Defender and whether you allow people to see exclusions, it would require elevated rights. Good. The next one, well, we had a new CVE this month, and one of the recommendations mentioned in the CVE was to actually look for suspicious renaming activities of computers within the network. So I was curious whether I would find such information in the device network events. The device event, so from Defender for Endpoint. Let me get back there, which is not the case. So pushing hard, I was like, okay, is there anything, device info? And the only thing in the end I could kind of, settle down on, okay, the hardware UUID. So if that attribute is inventoried by the vendor, and if someone renames a computer, and I did so, as you can see here, that I have multiple computer names. Again, on the device name count, on devices that have the same UUID, it could be most likely be a rename. Of course, again, it could be legitimate, but usually if you ping this down and you extend the query, for example, to only domain controllers or any other critical servers, then you might have a problem if that wasn't done by your IT staff. When you have the vendor for identity, the whole story becomes a little bit easier because in directory identity events from MDI, we do have account name changed as an action type. And within there, basically, there's not much to do. Microsoft and the vendor provides us with all the data. So here again, we see the from and to, and of course we could monitor for that as well. So here I renamed my device from client 09 to client 09 attack. Then a contribution from my fellow colleague Loris Ambrozzo, who I'm fortunate to work with. He just posted something today, and this is a query to basically identify who is still logging on with the default administrator account. And this could help you maybe to find some use cases for Windows Labs if you haven't deployed that already. So also take a look at Loris's KQL contribution. And last but not least, I'm going to pass it back to Johnny for the closing.
Cool. So this month, what I did, I was working on the DeviceTvmInfoGathering table, not due to the blog post of Bert-Jan, but for my side, it was about the rings, because we had the CrowdStrike event a while ago, and I was wondering, hey, how can we look at this from a angle where we can see, okay, how many devices are in separate rings, and how can we make sure that we have the 10% or whatever percent that you want to have. So I started looking at the device TVM data because it has some nice content. So basically, device TVM info gathering table. It's collecting data from all your endpoints. And basically, it has a lot of cool information about your AV version, the engine version, your platform signature. Those are the three basics. You have the platform, then the engine, and on top of that, you have the signatures. That's the layering of the beast. And it also holds when did your scans complete. I have some good friends who made a logic app, for instance, which runs every now and then to see what the latest full scan date is and maybe run some additional scans on devices. That's some cool use cases. You have some crypto data, so if all the TLS versions are enabled, and you have the data from the updates. When did it got updated? When did it got released? Also, you have these values, which basically show, hey, are the items up to date or not? And so in here, you have a lot of good information, also the ASR rules. So basically, I started playing around and I thought, well, let's first just unpack this table to work with. Nowadays, I think you don't even have to unpack it anymore because it moved to a dynamic already. Let's just double check that one. So here we have in the device TVM info gathering, we have additional, which is already a dynamic. So in the other events, we could actually leave this out. And then we, of course, need to change this. So, and now we got all the items from the variable to be here. So the next step was I was thinking about, hey, I want to see everything related to the signature data, because I was working to see the rings, because you have the, let's go back to the screen. Over here you have the staged ring and you have the broad ring, and basically you want to make sure that 10% of your devices is in the staged ring, and then if everything is working, you have some hours before the broad rings get released. So you want to make sure that you have enough devices in the staged ring. So basically, if we look at the ring, we have 4 and 5. In total, there are 5 levels from preview all the way to critical. Critical meaning your domain controllers and stuff you want to have a relaxed schedule on. But for signature, it's basically 1 or 0, which is the auto one, and then you have 4 and 5, which is the configured broad rings, the stage and broad. So this was working quite okay, but then I got wondering, how do I know that my devices are properly updated based on this? Because we have the publish time, and sometimes it can be that the device is turned off, but then it might slack around based on the version. So in the DeviceTvmInfoGathering table, we also have the last seen time. And the last seen time is when the device actually got last seen by this table. This value runs every hour, 2 hours, somewhere in between mostly. And this is a good way to compare your published time against the last seen time. Because if a device is turned off, you still can get events. Because if we look at this one, timestamp, that's basically when the data got collected. And even if a device is turned on, the timestamp still gets renewed, because basically the info gathering looks at the table and it sees, hey, okay, so the last time was this, so it will get updated always, even if the device is turned on or not connected.
You mean turned off?
Exactly. So what we can also do then, of course, is if we join it to the last record with the argmax of the device info table, that way we can see all the additional information of the device. Because maybe we want to filter for machine groups. If you want to make sure your rings cover all your machine groups, for instance, you have several factories, and at one factory you want to have 10%, and in the other factory you also want to have 10%. So you want to be able to look at the machine group data. Because over here, the machine group data is collected from the device info. So basically, in my own small tenant, I have a machine group with my test VM, and then I have a machine group with new devices. But as you can imagine, if you have a larger environment, then you will have several layers of these. So then you want to make sure that it's scheduled well, so you get all the information. But there's a lot of cool informations in this table. So I would recommend, if you have the Defender for Endpoint, play around a bit with this, play around with the rings, look at the publish time. And it's really cool to make sure that your devices are configured properly based on the rings, but also are updating properly, and also your scans are working if you plan them.
Yeah, maybe for the audience who's not familiar with all the technical details. So while Johnny was talking about rings, he's basically referring to the configuration that you can apply through Intune, group policy. It's basically a Defender antivirus, configuration setting, where you basically specify for the platform, for the engine and definition updates. Historically, you will configure how often it should update. And historically, it's actually wrong because this rings thing is not something Microsoft now came up after this little disaster with the other product, but those rings were, already available. I think almost 2-3 years. You just had to know that there was a separate administrative template for GPO somewhere on a Microsoft employee's GitHub, and it was not in the official administrative template files. So once you have defined in Intune, or whether you use config manager still with random collection assignments, the outcome of whether you specify broad deployment, and I don't know by heart the other definitions, but the slow deployments, that reflects in your ring number. Correct, Johnny?
Yes, that's correct.
Yeah. And actually, what could be cool, maybe as an inspiration, Johnny, because who knows those numbers? So you could actually extend this with some cases in your query to basically translate the numbers into human readable description. Yeah.
So the thing is, I did make it, but for some reason, what happens? You have basically 0, which probably is not configured, until 6, which is critical. But for some reason, sometimes the numbers are a bit off. For instance, I wouldn't expect to see item 1, which is there, because if you look at the CSP config, you have 2, 3, 4, 5, and 6. But then sometimes you see, if it's not configured, you see 1, sometimes you see 0, sometimes you see for instance, if you don't configure your signatures, then it will have the broad ring, which is 5. And
okay.
sometimes
you
see
have
5
multiple ring values, or just one ring value?
How do you mean?
Is there just one ring value in this table, or is there a ring value for the 3 different settings that we can make? Because I'm just thinking loud as we speak, whether if you tell me there's only one ring attribute, whether that's maybe a combination of the 3 individual values that you can set.
No, they each have their own rings.
Okay. Yeah. Okay.
Let me see if I can grab it from the Learn page. If we go to, I guess it's this screen. Yes.
I'm sorry to interrupt, Johnny, but I really have to drop, unfortunately.
No worries.
I'm sorry for making this the longest KQL cafe ever, but again, thank you for your time. Thank you for having me, and hope to see you guys soon.
Bye, Koos. Thank you.
Thanks for joining
Bye-bye.
us, Koos. See you soon.
Thank you. Bye.
So if we look at this specific, this is for the engine updates. We can see we have 0 to 6, where 6 is critical, 2 is the beta channel. And this works if you also look with PowerShell. If you set it to beta, then you will get 2. If you will set it to broad, you get 5. So this basically works, but for some reason I'm not sure why I got a 1, for instance, but that's something still work in progress.
Okay.
Because also, if you look at the other channel, you have the engine, we have the platform update channel. Here you have the also 2 to 6. And if you look at is it intelligence? No, definition. Channel.
Okay.
Platform security intelligence updates. Okay. So you have 4 and 5 here, but it's still a bit off.
Yeah. Okay. Well, I suggest share your query and let's see what the community who is using Defender, if they have configured those channels, whether they maybe have some other telemetry. Yeah, definitely important that we can rely on the telemetry we're getting there. Good. So yeah, this was a long one, or a longer one. Thanks for those that hung out with us. Again, November 8th, mark your calendar. We'll be broadcasting live as of 2 o'clock CET. And otherwise, we'll see us back in November as well at the KQLCafe show. And then we will have with us, let me take a look, Mehmet Eugene again. He has been with us before, and he's also always, again, candidate for super cool content. So stay tuned. And we're also already working for our guests in 2025. So yeah, thanks for following us. Thanks for being here, and wish you all a very nice evening or a rest of the day, wherever you are. Bye.
Thanks all.